I think what Ms. Dibiaski is trying to say is that the idea of sitting tight is an extremely dangerous.
Thank you.
I can totally relate to the frustration of just not getting through to people. Hello and welcome. As you saw from that clip, I'm going to be reacting to Don't Look Up on Netflix and hopefully comment on the more scientific aspects of things. So enjoy. Alright, so that's a telescope. It's an observatory to be clear. That's Carl Sagan. So we're up to a good start. It was a fairly accurate representation of a telescope, and even though you won't be working while inside the telescope, I think they're doing it for cinematic value, and that's okay. By the way, on this paused screen over here, it says SN_survey, which probably means supernova survey, and that's when a telescope looks at different patches of the sky and compares it to the past images and sees if there's some new shiny object that appears that's a supernova. And you have that underscore field 0005, that's probably one of the many fields of sky that the telescope is going to be analyzing in this survey. Okay, so there's a laser coming out of the telescope, and this is actually a very interesting tidbit in how some of the telescopes work. So if you have ever used noise cancelling headphones, what it does is it records the ambient noise and then it plays it back to you inverted so that it cancels out with the ambient noise and you only hear the thing that the earphones want you to listen to. The principle here is pretty similar, where basically the laser creates an artificial star in the sky, and because of the atmospheric turbulence, that star is going to be distorted in some sense. And mind you, the computer knows how the artificial star is going to look, so it can calculate what the distortions are and then it can subtract these distortions from the rest of the image, and voila, you have noise cancellation in telescopes. So that was a pretty enlightening first 2 minutes of the movie. That's an interesting interface. Okay, so looks like she discovered something like a comet, although the images were a bit too clear, so I don't think using even the most advanced telescopes in the world, you'll be able to find a brand new comet with that clarity. I mean, if that clarity is available, some algorithm or the other using automated searches would be able to find this comet. I'm pretty sure about that. But something like this probably actually does happen. You're looking for supernovas in the sky. So basically what you do is you look at a picture of the sky and you take a picture of the same region of the sky sometime later, and then you overlay both of those images and you see if something has changed in the two images. Because supernovae are basically exploding stars, so when they explode, they basically shine much brighter than the star itself. And so there's a clear difference between the earlier picture and the later picture. And you see a very similar thing when you try to detect asteroids and comets. Because earlier in the picture they wouldn't be visible, but because they're moving very quickly and very close to us, they'll enter the frame and then you'll be able to detect it. So probably quite plausible actually.
To Comet Dibiaski, right? Cheers. All right. Look, it's gotta be an Oort cloud comet just based on where you saw it. Probably the last time it was this close to the sun was long before human civilization. Look at the arc on that thing.
So the Oort cloud is basically a cloud of dust and icy materials from about 2000 astronomical units from the sun and beyond. And that's where we think most of the comets come from. So if there's some disturbance in the Oort cloud, what may happen is one of the comets may just enter the solar system from there and go towards the sun because of its gravity. And this happens all of the time. The orbits are extremely elliptical because you go very close to the sun and you go all the way out to a few thousand astronomical units, maybe tens of thousands of astronomical units. And so the orbits could take between 1,000 and a few 100,000 years to traverse for the comet.
How would we find out the comet's velocity in orbit, Professor Mindy?
That is a good question. Well, this will be fun. I haven't done orbital dynamics since grad school. Question is, what would Carl Sagan do?
Yeah.
He would take it back to first principles.
Okay, probably if Carl Sagan left today, he'd probably just send the data to one of his orbital dynamics colleagues or just enter the data that they have into a software. Although I don't think there's enough data in those 4 frames to have any meaningful extrapolations on where the comet will go a long time down the road. And definitely so if you're doing the calculations on a whiteboard.
You have a good approximation according to Marsden 85. Now that we have the comet's orbit, we will check the ephemeris, and that will give us the distance between the comet and planet Earth.
So by the way, the ephemeris is just a data set that tells you where in the sky a certain object is going to be. And because they probably have the orbit of the comet with respect to the center of the sun, you need to account for the motion of the Earth and where it is at different times of the orbit of the comet to actually tell you where exactly the comet will appear in the sky.
Why does the ephemeris keep getting lower and lower? Professor Mindy?
So if I was in that situation, I'd probably just redo my math on a computer because, I mean, it's probably a big deal, although they're just using, 2 to 3 significant digits in their calculations, which is basically the number of digits sandwiched between the leading zeros and the trailing zeros and all of these numbers that they're using. For example, if you were to write this 49.7, the number of significant digits there is 3 because you can write it as 0.70000, but the leading zeros have but the leading zeros have no meaning, and the trailing zeros it's not really right to use them because you don't know if those numbers are 0 or some other random digit. And so the number of digits used in your calculations somehow tells you the amount of uncertainty you have in your calculations. For example, if you're writing 49.7 without a plus minus something, then it is natural to assume that the error over there is somewhere around plus minus 0.1. I don't think you can come to the conclusion that the comet is going to hit the Earth because the Earth is basically the width of a pinhead on a gigantic bullseye board of the solar system, right? So I'd probably do a more thorough calculation on a computer rather than just worrying about it on a whiteboard like this.
I'm on hold. She's calling a Dr. Oglethorpe. Who is that? Oh, Jesus Christ. I'm gonna put them on speaker.
Dr. Oglethorpe, head of the Planetary Defense Coordination Office? Is that a real place?
That is a real place. Yeah, it is a real place. Okay.
Really? How large?
How big we talking? We clocked it in around 5 to 10 kilometers wide.
About 5 to 10 kilometers wide.
That's a big boy.
That is a big boy. That is probably half the diameter of asteroid that is said to wipe out the dinosaurs. Although what bothers me is the fact that they are not sure what the exact size of the comet is. And if they have the orbit of the comet to such accuracy, they know the distance of the comet from Earth, and then you can look at how big the comet appears in the sky, and you can very accurately estimate how big the comet is. So that confuses me because I'm not sure how certain they are of their calculations at this point.
I've been running it all day. I keep getting the same result. A direct hit of Earth in 6 months and 14 days.
Me too.
Matthew.
By the way, the time frame is sort of accurate because all of these Oort cloud comets, we've not discovered them yet. So when they come towards the center of the solar system, that's when we have the chance to first look at them and identify them. And because they've been falling for a very long time from all the way from the Oort cloud to the inner solar system, they have extremely high velocities as well, because of which if we figure out that one of them is going to hit us, we'll probably have a warning of about 8 months to a year before it actually does hit us, which does make it scary, but that's exactly why NASA launched the recent DART mission, and it was quite successful. So if we have proper funding, we'll probably have a lot of those DART mission satellites packed up in a box ready to go. So whenever we discover that an asteroid or a comet is headed our way, even if the warning time frame that we have is a couple of months, we should be able to knock it off course so that it just misses the Earth.
The president should be here shortly. She's already been briefed. Correct, Scott?
That is correct.
Are we really about to tell the President of the United States that we have just over 6 months until humankind, basically every species, is completely extinct?
I wouldn't be that dramatic.
Exactly what we're about to do, yeah. Oh gosh, oh gosh.
Okay. That's a completely understandable reaction. Although about the extinction level event, yes, 5 to 10 kilometers is a big comet, but I don't think it'll be nearly enough to wipe out the entirety of life on Earth. We've had much bigger impacts, and life has not only survived, it has thrived throughout all of this. Basically, it's not like the Earth is going to blast open after that impact. Depending on where the comet hits on Earth, there are a lot of different scenarios that can happen, all the way ranging from super tsunamis to volcanic eruptions to humongous earthquakes. There will be a lot of instantaneous destruction, but the extinction part of it would probably be a very long, drawn-out process where, because of the strike of the comet, the climate of the planet would change drastically, and because of that climate change, a lot of species would not be able to survive, because of which food shortages will occur in a lot of ecosystems, because of which a lot of species will go extinct, because of which a lot more food shortages will occur, and so on. And that is what will cause the mass extinction in the long term, and not the impact by itself, especially not for a comet that's 5 kilometers in size. But yes, the destruction would be unimaginable because we have not seen anything of that kind in the entire history of humankind. Probably all nukes combined would not be able to do as much damage as this one comet.
Madam President, approximately 36 hours ago, PhD candidate Kate DiBiase here discovered A very large comet.
Oh,
Yeah.
good for you.
A comet between 5 to 10 kilometers across that we estimate came from the
Again, the range.
from the Oort cloud,
Wow.
which is the outermost part of the solar system. And using Gauss's method of orbital determination and the average astrometric uncertainty of 0.04 arc seconds, we then asked.
Whoa. What the hell
I'm
is
so
what?
bored. Just tell us what it is.
What?
Seriously, stop.
Stop
What Dr. Mindy is trying to say is that there's a comet headed directly towards Earth. And according to NASA's computers, that object is going to hit the Pacific Ocean at 62 miles due west off the coast of Chile.
Okay, so Dr. Mende here is trying to explain the process by which he came to that conclusion, because in science that is as important, if not more important, than the conclusion itself. The issue is that's not how you talk to people who haven't had scientific education, and it was very difficult for me to convey scientific ideas to different people as well, because the priorities that a scientifically minded person has are very different from the priorities of what the rest of the people do. And for that reason, there's this gigantic gap between the scientific community and the rest of the public. And this gap has to be filled by some people. And unfortunately, very few people have been able to come and bridge this gap, or at least bridge this gap successfully. And there are a few reasons for why this happens, but the bottom line is we're not taught how to talk to the rest of the people, because we are taught how to do our work best, as is everybody else in this productivity-driven economy. And so the communication part of it, that is in case of science extremely important, sort of goes under the rug. And I have been practicing talking to people. I talk to people about science at every opportunity that I get. I try to make it interesting and sensational, because we don't only want to talk to the general public that's interested in science, we want to talk to the public that's not interested in science and that finds it boring, and we want to convey our ideas to them as well, because the ideas of science, unlike the ideas of religion or politics or pretty much any other thing that the entire world has ever been able to come up with, the ideas of science are the most important to communicate, because they are the ones that guide us more than any of the other ideas, that and the philosophy of ethics. So yes, scientists definitely need to work on that PR. And there's this amazing book by Carl Sagan. I think his name keeps on popping in this video, but there's this amazing book. It's probably my favorite book in science. It's called The Demon Haunted World, that I'm going to do a review on in a couple of days. It goes into this very problem in amazing depth. And once again, they talked about the astrometric uncertainty. Like I said, the uncertainty is the most important part of calculations like this, because hit or not hit is a very binary thing, and you need to be absolutely sure that you are picking the right one out of the two. And so the astrometric uncertainty sort of gives us an idea of how certain we are that it is actually going to hit us. And they said that the uncertainty was a fraction of an arc second. So let's just talk about what an arc second is. So if you look at the entire sky, if the dome is about 180 degrees and then there's the horizon, every single degree is divided into 60 arc minutes, and every single arc minute is divided into 60 arc seconds. And so an arc second is an extremely precise measurement of the region of a sky. And that probably lends some credibility to the fact that they are extremely sure that the comet is going to hit Earth. Although that does not explain the 5 to 10 kilometer range, unless you're not sure how to define the boundary of the comet.
And I'm trying to articulate it the best I can. I don't know.
Madam President, this comet is what we call a planet killer.
Okay, that's probably a good way to explain to them.
Am I to understand correctly that after all of the information you've received today, the decision you're making is to sit tight and assess?
I think what Ms. Dibiaski is trying to say is that the idea of sitting tight is an extremely dangerous.
Thank you.
I can totally relate to the frustration of just not getting through to people and not understanding the severity of the situation. I mean, I've talked about climate change and the climate crisis to a lot of people, and for some reason they're just desensitized to that entire topic. No matter how many well-established numbers you throw at them, they just don't seem to understand the consequences of that, even if you lay them out flat in front of them. And it is for situations exactly like this that we need PR people for science. They can convey the gravity of certain situations and exactly lay down the plan of what needs to be done after what. I mean, we did see something extremely similar during COVID, and we are seeing something extremely similar during the climate crisis as well. And so yes, I don't think it's exactly the fault of the general public or the politicians, no matter how much we try to make it their fault, because they simply are not equipped with the understanding of what all of this means. It is definitely 100% the job of scientists to gain that respect and be able to influence all of this, if not run it.
Philip says he knows a reporter from the New York Herald who will talk to us. Really?
Good. He's a heavy hitter, and I'll reach out to more of the scientific community on the down low.
I just feel like this isn't what I do,
You're just telling a story. Keep it simple. No math.
But it's all math.
Exactly. Yeah, exactly. That's the issue, because everything we do is math, and math for some reason turns people off, be it because of bad teachers or because of the extremely terrible math curriculum that most people are forced to slog through. I mean, I hated math in school. But yes, whenever I'm trying to explain something to a populace that, is not primed to listen to me and I have to fight for their attention, I definitely do not want to include any tidbit of math except a couple of percentages here and there. And even that is in the worst case scenario when I cannot make do without those. So yes, that is good advice in this situation, even at the cost of a lot of scientific minded people telling them that they don't have credibility if they don't really show hard numbers, because that is not the point of scientific communication at the population level.
I was monitoring exploding stars to help measure the expansion of the universe, and
For your PhD, right?
Yeah.
I saw something.
So they've definitely started to do a much better job than they did in the Oval Office. Let's talk a little bit about these exploding stars that she talks about. So the exploding stars are basically supernovae. And yes, you do use them to measure the expansion of the universe. So let's take it one step at a time. The universe is not exactly static, it is expanding. And by that, what I mean is the distance between, let's say, our galaxy and some galaxy far, far away, if you ignore the actual motion of these two objects, these two objects are still going further and further away from each other, and that's simply because the space between them is expanding, and this is happening at every single point in the universe. And this expansion of the universe can be measured if you just see how quickly things distant away from you are going away from you. Basically, if two things are going away from each other much faster, that means the space between them is expanding much faster. And the measurement of this expansion is extremely important because it helps us a lot with our cosmological theories, which is basically the theories that tell us how the universe actually began, the Big Bang, inflation, and so on. And it also helps us measure the distance from us to very far away galaxies. So in this equation over here, the d is the distance between us and the object that we are looking at. The v is the velocity at which the object is moving away from us. And the h over here is called the Hubble's constant. It tells us how quickly the space is expanding. And this number h is extremely important for cosmology. Just like, let's say, the charge on an electron is extremely important for quantum mechanics. It's a parameter that puts everything else in perspective. Now, believe it or not, in this equation, it's extremely easy to find the v actually. That is the velocity with which something is going away from us, and that's because of something called Doppler shift. Basically, if you hear an ambulance coming towards you, you'll hear a much higher pitch, something like tino nino, and when it moves past you, the pitch suddenly drops and it goes like tino nino nino. And I'm sure you can relate to this absolutely boyish mimicry of the sound of an ambulance. But the point is, sound isn't the only thing that follows this Doppler effect. Light does it too, although the equations are slightly different. But basically, if something is coming towards us, the frequency of the light that we receive from that object is high, and when something is going away from us, this frequency that we receive is low. And so by measuring that frequency, we can estimate how quickly something is moving away from us. Although the distance is an extremely difficult thing to measure, because clearly we don't have a measure tape that is billions of light years long. Interestingly, this is where the supernova comes in. So let's talk about this lamp. When I put it very close to my eye, it's sort of extremely bright, and when I take it away, it sort of dims down. And let's say I put it in some other building over there, then I'll barely be able to see it. If I put it on the moon, I personally won't be able to see it. I'm not sure if some telescopes are strong enough to see it even. And so basically that's the same principle that these astronomers use to measure distances in space. There are some kinds of supernovae which are called type 1a supernovae. They are some sort of standard candles. Basically, they explode at the same brightness every time they explode. So if they're extremely far away, we'll see that they're dim, and if they're extremely close to us, we'll see that they're bright. And depending on how dim or bright they are, we can identify this parameter called distance, and using the Doppler effect on the supernova, we can find out the velocity, and then we can just divide and find the value of h. And of course, there's some statistic that goes into this, but of course, if you do it for a lot of supernovae, then you sort of get an estimate of what this h naught is. Okay, so that was quite a tangent, but that's basically what Mr. Biaski is doing.
Oh my God, honey. This guy doesn't even know what a heliocentric orbit is, and he's calling me a crackpot.
Yes, I've had far too much of that.
Jewish billionaires invented this comet threat so the government can confiscate our liberty and our guns. Hashtag don't be scared.
Yeah, so this is extremely common. I mean, if you go to the public and even if you provide an extremely logical, airtight argument that even slightly challenges their dearly held beliefs, this does tend to happen. And in the age of the internet, everything is a belief. So no matter what you say, if a large enough sample of people did listen to you, there will be keyboard warriors like this. I mean, I get that on my personal Instagram account and that barely has like 1,000 followers. I think that's a good place to stop because the rest of the movie is more of a political sketch rather than something scientific that I can comment on, and I don't want to give you any more spoilers in case you haven't watched the movie. I think in terms of scientific accuracy and the way the world reacts to scientific news, this hits right at home. I don't think I need to be the one to tell you that the climate crisis is the biggest crisis we're going to face in the next 10 to 15 years, even if the Russia-Ukraine war escalates into the nuclear territory. It is that scary. The pace at which our climate is changing, even accounting for all of the recent legislation that has come into place, the impact is definitely going to be much more severe than a 5-kilometer comet hitting right at Earth. And I think that is the beauty of this plot. The urgency and the gravity of the situation portrayed in the movie is not at all higher than the climate crisis that we are facing today, and that is what makes it much more bone-chilling, I suppose. So let me know in the comments if there are more shows that you'd like me to react to, and I'll see you in the next one.